Welcome everyone. We'll get started in just a moment. Hello, this is Leah Freeberg from Fluke Reliability, and thank you for joining us for this Best Practices webinar session today. So you likely know Fluke as a test tools provider, and you may also know that we produce some of the industry's favorite reliability tools, from infrared cameras to vibration meters. But you may not know that many of the measurements that our tools collect now flow automatically into EAM systems of record. Happens via a framework that we call Fluke Accelix. Our goal at Fluke Reliability is to better connect asset management data and teams with asset management systems to drive connected knowledge. And of course, that knowledge depends greatly on best practices in condition-based maintenance. So that's why this series of webinars explores reliability maintenance strategies, and that's why we feature speakers from a variety of expert backgrounds. So before the presentation, we have a few housekeeping items to go over. Today's session is being recorded, so your phone lines will be muted to minimize background noise. We will be answering questions during the session and afterward in the Q&A period. So take a minute now to find the questions tool in the GoToWebinar dashboard, and please feel welcome to submit questions as we go, and I will share as many of your questions as time allows for our presenter to answer. If we have unanswered questions at the end, we'll follow up with written answers. If you'd like to receive the slides from today's presentation, just let us know during the survey that will appear at the end of today's session. So don't hang up until that survey appears and you've answered the questions. We're also happy to send you a certificate of attendance after the webinar. You'll see a question on the survey about that, about getting a certificate. Answer yes, and we'll send one to you. A recording of this webinar will be available on the Accelix.com website within a day or two. And that's it for housekeeping. So now for the main event. Today we are very pleased to have with us Craig Hassey, a thermal monitoring expert with Fluke Process Instruments. He'll be presenting on continuous thermography as a condition detective, the secret sauce to uptime. Craig Hassey is a thermal imaging and strategic account sales manager, a member of the Fluke Process Instruments team since 2010. He has more than 20 years in the automotive manufacturing industry developing welding automation systems. Craig specializes in using thermal imaging and infrared technology to support processes. Welcome, Craig. Thank you very much for being with us today.
Thank you, Leah. Appreciate the invite and also the introduction. Hope everyone can hear me all right.
Sounds good.
All right, great. So that's a quick overview on me. What I'd like to do is get into the presentation, show you what we are going to go over, and let you ask questions as I go through the process. So together we are Fluke. What we have here is, you'll see Fluke at the top. I'm sure most, if not all of you, are familiar with the handheld tools, the voltmeters, the thermal tools that all support your daily lives. But what you may not know is that under Fluke are a variety of different companies, different umbrellas that support a variety of different industries. Fluke Process Instruments, as you'll see on the far right, Fluke Process Instruments is all based on infrared sensors that are designed to be built into systems. They are designed to be built into your manufacturing process to review either process or product and to respond to parameters set by you, the user. So Fluke Process Instruments, process being a key word in that name, allows us to help you, the customer, control your process through various production and reliability needs. First poll question, do you use any of the following in your current maintenance practices? Please do respond to this so we can get a feel for what you currently do use or in some cases do not use.
Okay, audience, you should see the poll up in front of you and you know what to do. Click only one answer. So which of the following do you use in your current maintenance practices? Handheld thermography, route-based or troubleshooting, continuous temperature sensors, both handheld thermography and continuous temperature checks, or neither. We'd like to get about 3/4 of the audience selecting an answer so that we know what level you're at and what you've used so far. And we're almost there. I'm going to give it about 10 more seconds and then I'm going to share the results. Okay, get those votes in. Good. All right, I'm going to close the poll and share the results. So Craig, we have 45% of the audience using handheld thermography, route-based troubleshooting occasional. We have 4% using continuous temperature sensors, and we have 30% who are using both, handheld thermography, continuous temperature, and 21% who say neither.
Okay, so then that tells me that quite a few people on this webinar understand, or at least have a basis understanding of thermography and how it can be used as a tool. And with that said, I would like to point out that the handhelds are fantastic tools. They definitely have their use, and they're able to collect data and present a response. What we're going to do is we're going to go into a little bit more in depth on what a fixed thermal imager or fixed thermal product can do for you. And that leads me into my next slide.
Excellent. Back to you.
Thermography is a condition detective. I like to say, and many people have heard this before, an image shows a variety of things. It says 1,000 words. What we're showing here is a ladle. So this is in the steel industry. And what we're showing here is a very nice, colorful view of the product itself. And in this case, everything I'm going to show you here has been taken with the TV40. This is the Fluke Process Instruments product. This is the TV40 with thermal view software. And this is a fixed mount product. The fixed mount product in this case is something that is always looking. So what I had said previously, where the handhelds are extremely useful and handy, they are. They all have their purpose. Where you would see an advantage with a thermal imager is if you're looking at something that may be critical to your facility, be that in continuous operation, be that in safety, be that in a variety of different process control arenas. So here what we have is color, and color being an indicator of temperature change. What we are looking for here is to understand what is extremely hot on this product, because in the instance of a ladle having molten alloy inside of it, what we don't want is we don't want the outer skin becoming so hot that it becomes to melt. Once we have that, we have a breach, and that becomes both a safety issue as well as a production issue. In this case, what we're doing is we are trying to give you as much information as possible. What we're doing here, if you look at the lower two slides, is a area of interest. So you'll see the dotted lines across the bottom here. In this area of interest, what we're looking for is we're looking for a preset temperature range. The preset temperature range is something that was established by the user. And what they're looking to see is if areas of the ladle get beyond that actual temperature range, because that can then be a concern that we're getting into a position where we need to take this product out of service and put it into position where it needs to go in for repair. So what you'll see here is, I'm hoping you can see this rather clearly on your screen, a cross-hatched section on this surface. It's better shown in this black and white video. This is a lead indicator that in this area in which the thermal imager sees, the parameters established, the actual ladle here is getting beyond that, and therefore generating an alarm. And that's exactly what we're showing here. We'll go more into the software and its capabilities, but key differences between a handheld unit and a fixed unit. Fixed unit is always looking, it's always trying to make sure that it's giving you data consistently day in, day out. Handhelds are definitely fantastic tools. They are able to go and show you similar views of what we're doing here, but they're not doing it 24 hours a day, and they're not doing it 7 days a week. So here, with a fixed product, the advantage here is being able to continuously see and monitor temperature on critical products. It's important to understand these images because this is something that will potentially change over time. And if you are not in front of this ladle every day, all day, you would not capture that with a handheld. You would, however, capture that with a fixed product.
Craig, we have a couple of questions coming in already.
Mhm.
And I'm going to try to give you a couple that are short answers that everyone might have in mind. The first one is about color palettes. Does the tool have color palette options, and are there particular recommendations?
Absolutely. So if you'll notice, you'll see here my circle with my cursor. I hope you can see that. Right here, you'll see palettes. This button here can change. I think we have 12 different color palettes. So in this case, you have the multicolor. I think this one is referred to as rainbow. And down here, this is black and white. You can go through a variety of different palettes that best show the visual image you're trying to see.
Mm-hmm.
In fact, what you'll see here is you'll see the black and white showing the hot spot in yellow. So it's extremely evident where that spot is and where you may need to do service on your product. As far as giving a recommendation, it's hard. Every surface is different.
Mm-hmm.
What we usually recommend is that when a system is first set up, uh, we take a look at it as it's running through its process, and we filter through the different palettes to present the best color palette for what you're trying to see.
Yeah.
There is no one correct answer for all applications.
The other questions that we have coming in have to do with thermography itself, such as which surface temperatures can you measure, right? Such as aluminum slabs and so forth. I don't know how much you're going to get into that, so if you want to hold that question for later, that's fine too.
Yes, so that can be very detailed.
Yeah.
What we tend to do is we tend to um, say that most products you can review or you can use a thermal imager on. I think I heard aluminum or aluminium.
Mm-hmm.
That is extremely reflective. However,
Mm-hmm.
it depends on the application, and we always recommend that we do a demo to verify that the
Yeah.
product works as the customer would like it to be. So you can go into a lot of detail on that question. So that's just kind of a quick overview.
Perfect. Back to you.
Okay, moving forward. What do you get from fixed automated thermography? So I had mentioned that a fixed unit is always there. It's an extra set of eyes. It's watching 24 hours a day, 7 days a week. So when you're busy doing other things in your daily lives, you have a product that actually is watching your critical equipment, your critical assets for you. Where the power or the secret sauce in a fixed unit comes in is the software. Having the ability to provide a response without human interaction. So once the imager is established on what it's looking at, you can then go into the software package and do a variety of different things. You can create AOIs. I think you heard me mention that previously. AOIs are areas of interest, and what I'm showing here is a couple of areas. What we're looking at is the temperature of a bearing and the temperature of a conveyor, or excuse me, a belt. So you can do a variety of different things with the AOIs. You can either show one temperature or max temperature, or you have the ability to show max, min, average. With these AOIs, you can then create alarms, and you can create alarms off of either one temperature, or you can create alarms off of all three. Depends on what you're trying to do. The system is flexible. And this is really up to you, the user, to decide how you want to set up your system. So you may want to know a minimum temperature as a warning, before it gets to your maximum temperature. So you can alarm off the min, but still show the max. With AOIs and alarms, what you can then do is you can program the system to respond to those. You can either collect data by just picking up the temperature reading. You can actually take a visual if this goes into alarm mode. You can take a video if this goes into alarm mode. That said, you don't have to go into alarm mode to program the software to take images. If you want to record data and you want to record an image once an hour, once a day, once a week, once a month, the system will allow you to do that. What we are trying to do is allow the user to collect the data that they want, and that's helpful to them. So there's quite a few different things you can do. You can also see a continuous visual image. This is been quite useful for a lot of our customers. We do get that request quite frequently that they want to be able to see this on multiple monitors within their facility. So if this program were to be networked, you can actually remote access into the imager and see what the imager sees live from a different building within your organization. You could also access this from outside of your organization if you have this networked and you can get through your firewall. So an instance where you might have a technician gets an alarm, has a concern, wants to talk to somebody about it, but that person is off site, they could remote access in and see what the tech is seeing live to be able to have a conversation about it. Along with that, what we get into is data collection. You have the ability to create profiles. You have the ability to do trends. You have the ability to do histograms. And all of this supports not only live feed, but also recorded feed. So if you were to go back into an old file, you can run that file and show what was actually recorded last week, last month, last year. Also, whenever you take the cursor and go over the surface, wherever the cursor is, allows you to see the actual temperature that the cursor is on. So data is worth a lot in that you can do a lot of research on previous images taken. So I had mentioned areas of interest in creating alarms and taking videos. Things that you can also do is if you connect up to an output module, you can trigger a relay, you can trigger a digital output, you can trigger an analog output. Depends on what your system is designed to do. And along with that, at its minimum, if you just wanted to create an alarm and send an email to a technician, to an operator, that is also possible with the software package. So I'm going to quickly go into the next slide here. Real quick, what you'll see here is the automation mode, and this takes us into the slide that would allow us to create alarms off of the areas of interest. You have a variety of different options, but I won't go into that because the software can be very detailed in with what you can do with it. So I actually have an embedded video in here, but for some reason it doesn't want to come up. I'm going to switch screens really quick and try and show the video, and then we'll come back. So if you can see that rotating, what I wanted to show, and pause it right here, if you saw it just a second ago, go back just a little bit, here we go. This bar here is in a green status. So if this were presented to an operator, what you would actually see is green. Green is good, green means go. Once we go into alarm mode, it now changes to red. So this is a additional visual that allows you to understand when something is out of the parameters that you establish. But what you can see here is that the software will change back and forth as alarms go in and out of play. And like I mentioned previously, what you can do is not only take a video or take an image of what is shown here, you can actually send an email to a technician. And that's actually what we're showing over here. So give me a quick second and I will get back into a better view. Okay, hopefully that is back up. So let me go through. Here we go. So I apologize, I do think this might be hard to see, but what we're showing here is we are showing an email that would be sent to an email address of your choice or email addresses of your choice. And what this does is it gets sent to the local address or person, and it shows you an image of what was triggering the alarm. In this case, please don't get confused here. This image is not this image. What I'm showing here is I'm just showing what an email alarm would be. And in this case, you'll see two different AOIs, areas of interest. This one is not red, but this one is. This is what triggered the alarm. And this is what me, if I was the technician, would want to go back and look into. And in this case, I would be able to understand what time it came, where it came from. If we named the target, it could give you the name. You as an operator have the understanding of where you need to go and what you need to research. Moving on.
Are you up for a couple more questions?
Absolutely.
Again, I'm going to keep these fairly brief, but you can tell you have thermographers on the line here. So the first question is, do people typically establish baselines?
Yes. So it is always good to have a baseline understanding of your system. I always recommend having a baseline so that you understand how things change over time. We all know that temperature of a system, depending on what kind of environment you're in, can definitely change from season to season. So knowing what you're up against ahead of time gives you a good feel for what parameters you should establish for alarm conditions.
Great. And one more. What are the gainful benefits between thermography or thermal monitoring and using thermocouples and other temperature sensors?
So we do sell spot sensors, and the major advantage of a thermal imager versus say a spot sensor or even thermocouples is that I go back to what I said before, an image is worth 1,000 words. A thermocouple is going to be in contact with a specific area. However, it may not show you exactly where the root cause issue or the root of the heat transfer is coming from. It is definitely an indicator that there is some kind of change, and that can be true for a spot sensor. Spot sensors, however, only see what they are focused on. Spot sensors can have a variety of different sizes, so you may have a half-inch spot, you may have a 4-inch spot. Anything in that area could potentially alarm on a spot sensor. With a thermal imager, you can physically go off of anything in the field of view to alarm, or what you can do is get into more in-depth review of what actually triggered the alarm or what is actually increasing in heat. So a fixed thermal imager or thermography gives you a lot more information, a lot more data, and much more flexibility, because I can create multiple different alarms, multiple different temperatures on anything in its field of view, unlike a spot sensor or a thermocouple.
Great, great answer. Back to you.
Okay, so moving on, what we have here is, again, going through the software and its ability to analyze what you have, what you see. I had mentioned previously that recorded images can be used for review. Well, you can also change the contrast. You can change the palette. I think that was one of the questions that came up. If you wanted to get more in depth or fine tune what you're looking at, that is possible in the software. You also have, I think I mentioned unlimited areas of interest, so unlimited amounts of AOIs. And with that, you also have the ability to do a lot of research with the software, as in getting closer to what the actual hotspot is. In this case, what we're showing is a zoom. We zoomed in 200%. We have a measurement tool here. We are capable of taking measurements to get an idea of what size this hotspot really is, if that is something that is important to you. You have the ability to see, again, what the temperature is live with the cursor, but you also have the ability to understand what the emissivity setting is at too. So if by chance you had an alarm that didn't seem quite right, you could go back and take a look and see if maybe something changed. Did someone change the emissivity settings? Because remember, a thermal imager is just like a spot sensor. You can change emissivity on these units. So something you always want to know. And then you have the ability again to see date and time. So with the software, you have a very intuitive package. However, one thing I'd again like to reiterate is once you establish the parameters and the alarms on a software package like this is an automated system. You do not have to continue to watch it. It now responds to what you have put in there as far as requirements, provides you the data when you want it, and is automated in that physically no one has to be there to help it out. It's helping you out. Case study. In this case, what I wanted to show is I wanted to show a real life situation. Here, what I'm showing in the thermal image is a transformer. And what makes this really important is that this transformer is actually within a vault that is unoccupied, and it is servicing or supporting a hospital. So it's a critical piece of equipment. Be it that it's unoccupied, we actually have a pan and tilt unit in this vault. And why that's important is because we're actually looking at multiple transformers, multiple switch gear, multiple components with one system. So one thermal imager, one pan and tilt, looking at many, many different components. But what I wanted to show here, and the reason why it was important for the customer to understand what they were looking at, is these are the bushings here. There are a total of 5. You have 4 primary connectors going to the switch, and you have one here that is for monitoring. What the customer wanted to understand was they wanted to understand if there was a 5-degree difference between either bushing. And they wanted to know that on all of these units in conjunction with one another. And what I mean by that is 5-degree difference between 1 and 2, between 1 and 3, between 3 and 2, between 3 and 1, between 1 and 5, or excuse me, 4. This can all be set up in the software so that it is constantly looking back and forth at all of these bushings to verify if something has gone out of parameter. This is doing this 24 hours a day. It's doing it remote in an unoccupied vault that is in the dark and no one is on site. This is feeding data always to a software package that allows you, the operator, or you, the person who has a concern in the asset, to understand the health of the product. You can understand what is going on with your system from your office, considerable distance away, to make sure you have peace of mind that the system is working as it should. And if you ever want to view this, I mentioned previously, you can actually go in remotely. If you are, say, at home, you can do this on your phone. You can do this on an iPad. You can do this on any kind of mobile device to view how systems are operating. So this is eyes on a system without physically having human interaction.
I have another question for you that several people have asked, actually.
Sure.
Any guidance on the distance between the camera and the object?
So there is always a relationship between spot size and the distance in which the target is away from the imager. So it really depends on what you're trying to achieve. Um, in an instance like this, spot size was not a major concern. We always like to say that we would want at least a minimum of 4 pixels on a target to be able to accurately read temperature. And in this case, the image or the distance in which this photo, I shouldn't say photo, excuse me, this recording was taken, the pan and tilt unit was approximately at its farthest point. So this target right here, about 60 feet. So I don't know what that would be converting to meters, but what you can see here is that we have a good resolution on the target. And because we have 2 different versions of imager, we have a 320 by 240 or 640 by 480, depending on distance and if there was concern about pixel size, the higher resolution gives you potentially a smaller spot size as a farther distance. So that's always a concern, but when we're working with a customer to set up a system, we take that into consideration to make sure that we are not out of um, parameter to be able to make sure we get those 4 pixels on the target concerns.
Okay, carry on.
All right. So here again, I'm showing you another electrical device. In this case, excuse me, this is an actual demo. This was taken at a power station at a steel mill. And this is definitely very interesting. This was purely going out to the customer to show the customer the advantage of using a fixed thermal imager on electrical components. And this being their main power station, obviously it's a critical asset to the company. And we walked out there and we set the system up, and we set these 2 AOIs on the switch. Now, if you can't see this very well, this is the switch right here. And what you'll notice is you'll see a 63-degree temperature here and a 73-degree temperature there. Normally, there's usually only a few degree difference between point 1, point 2, point A, point B, whatever you want to call it. When the customer first saw this, he thought, okay, there's got to be a problem. 1 minute ago, this was 63 and 63. All of a sudden, while you've been running this demo, we've gone from 63 to 73. So this was something he questioned our system on. So we went back and we turned the system off, turned the system back on, because we had just started the demo. Nope, we're showing a 63-degree temperature. We're showing a 73-degree temperature. We're seeing a 10-degree difference between these 2 points. This was very concerning to the customer because he felt that something was potentially wrong with our system. But we asked him to talk to his technicians and see if there was maybe something that changed in the factory itself. It was found out after a little bit of talking to different people that there was a very large industrial air conditioner that was turned on that supports an off-site trailer that holds different engineers. And it created such a power draw that it increased the temperature on this switch by 10 degrees. The customer was extremely happy that he found this, because what that allowed him to do was make a change in his system to avoid overloading this switch and creating a further problem. This is where we start digging into root cause. Why is there a 10-degree difference when there shouldn't be? Why am I seeing a temperature increase on a surface when I'm not expecting it? As I said previously, a picture is worth 1,000 words. If we start seeing a transition over time that something is getting hotter and exterior forces such as outdoor ambient temperature is not increasing or decreasing significantly, what is leading my product to get warmer? And that is a question that everybody wants to ask and start to follow so that they can identify what is really going on. Because again, I had said the secret sauce is data. The secret sauce is using software. It is also being able to know ahead of time when something is under an extreme load or in a point where it is operating beyond what would be normally expected, to start going into and doing more research, understanding how your system is working, understanding the health of your system so that you can prepare for the maintenance work that you might need to do versus having to react to a process that you've been thrown into. Pictures, again, worth 1,000 words. What we're showing here is we're showing an engine. And in this case, this is a heavy industrial engine. What the customer wants to see here is temperature change on this product. They are concerned about seals. So what we're showing here is both a thermal image and a standard view image. The thermal camera that we have, the TV40, does have two cameras built into one system, a visual as well as a thermal. And if you are familiar with the Fluke handheld products, you should be aware that there is a product called Fusion, where you can overlay both of these. That is something that also helps customers understand physically what they're looking at. Some folks have a hard time understanding what they're looking at purely with a thermal image. The Fusion side of things can bring things together, or you can have them side by side as we're showing here. In this case, the customer is looking at max temperature off of the actual exhaust side of a turbo, and they are concerned with over-temping this turbo so that they do not blow the seals. This is the same engine, and what the customer is looking at is they are looking at the exit gases going out and up into the turbo area. So again, they're looking at seals, and their primary desire is to understand if this gets out of the parameter that they have set. So they're just showing a max and a min here. What they want to understand is if they get beyond that max, and with that, they would create a response, so either an alarm or an output. And the outputs, as I mentioned before, can be either analog or digital. So those can be fed into a data collection system. It doesn't have to be only the software that we have, but if you have your own DCS, data collection system, that you'd like, the unit can be set up to work with setting out signals to that product via a variety of different ways. Moving on, here again, we're talking about seals. In this case, we're looking at a tank and we're looking at the exhaust process, but we're also clearly showing that we are getting a breakthrough. So there were some questions previously about utilizing a spot sensor or a thermocouple. If you had a spot sensor on this product, and let's just say you were looking up here or even over here, you would pick up the temperature of either of those areas. Same could be said with the thermocouple. You would miss the fact that the seal is beginning to fail right down here. That's where a thermal imager really proves its worth. And a fixed thermal imager is, like I mentioned previously, continuous eyes on the target. So if you don't have the ability to stand and watch the target over a full cycle or for many, many hours during a day with a handheld, this is an extra pair of eyes and an extra set of data collection tools for your arsenal.
We have a couple questions that seem to be fairly universal.
Okay.
First one is, how do you compensate for ambient temperatures?
So if ambient temperature is a major problem, what we do have is we do have the ability to take an input trigger into the software that would allow for the software to compensate for ambient temperature and take that into consideration on what the product is actually physically looking at.
Mhm. Okay. And then another that several people have asked, if you have a lot of assets to monitor, how do you choose? Is there an option to monitor multiple assets at once?
So I'm not 100% clear on that question. If you had multiple assets that the imager core could see,
Mhm.
so if you're looking at, say, an assembly line, and in that assembly line there were many assets, let's just say these are your multiple assets, you can create areas of interest along every one of these, and every area of interest can have different parameters set for alarm input or output. If you are talking about within your facility, you've got multiple tools, you can add, at least to this software package, you can add up to 4 imagers simultaneously looking at 4 different pieces of equipment. But it really comes down to if you're asking, excuse me, how do I choose between what's most important? What I would ask is, what is going to, one, be the most expensive piece of equipment to replace if it fails? Is that also the one that's going to take you the most time to replace and keep the production system down the longest? Those are the key features that we usually discuss with our customers. Is if you've got a product that's going to take maybe not an hour but a day to replace, or in some cases weeks to replace, those are extremely important assets to be watching. And we always recommend having those being, say, first tier versus maybe something that could take an hour or two to repair. So that's how we judge things, but that doesn't mean it's necessarily right for you and how you run your business.
Thanks. You answered actually several different questions that had come in. Well done.
Okay, very good. Well, we'll move on here. So thermography can be used in a variety of assets. A lot of questions come up about, what can I use a thermal camera on? How can I use it for the different things within my facility? And what we are showing here is an overview of real life applications, things that we do with our products, how our customers use our products. In this case, you've already seen the ladle, the steel ladle, where we have molten material in this, and what we're worried about is we're worried about molten material getting to the outer shell because we've had refractory breakdown. But you also have a variety of different pieces of equipment within this facility that could also be of high importance. So you've got high voltage cables going into the actual melter. You have a variety of different pieces of equipment that can be identified as critical and you may want to monitor. In a situation like the center photo here, we are looking at pumps and electrical motors. This may be an application where you would have a pan and tilt centrally located looking at all 4 of the pumps and motors simultaneously. This is something that would be able to, again, going to the multiple areas of interest, pick up multiple areas on both the motor and the pump simultaneously. And with a pan and tilt system, you can change the areas of interest per view. So the areas of interest for this pump and motor could be different than the areas of interest for this pump and motor. And the only reason why I say that it could be different is because, remember, this is moving and rotating. So you may have to move them or align them with different areas. We get into the coal pile here. Not only do we have thermal imagers looking at coal pile, don't ever want to fire on a coal pile, but we do have customers that use them on the actual conveyance system. Bearings that freeze up and drag across the bottom of a belt create problems. Customers want to know where those hot spots are, so having a thermal imager on a product of this magnitude gives them information that they would not normally have, and this is done remotely. Looking at tanks, you might say, well, why would I want to look at a tank? Well, we've had customers that utilize thermal imagery to identify how high these tanks are full. The temperature difference between the wall of the tank and the liquid inside is clearly seen with a thermal imager. Electrical hookups. Here we have a DIN rail mount type panel, and what we have is a variety of different cable feeds. Customers use cameras to look at critical power equipment or critical connections to, like I had shown in the previous video, or excuse me, previous view, areas of the wiring, and when certain areas become hotter, they can turn systems off or turn systems on. What you have to remember with a system like this, when you have the ability to utilize the software, generate outputs, take inputs, operate relays, this is all designed to support your process control. And in this case, if you found that a wire is getting too hot, maybe you want to temporarily turn something off until this can be further investigated. Below we have a kiln, and we do sell scanners into this type of application, but the advantage of a thermal imager on the hot side of this allows for a bit more in-depth data collection, because again, with a thermal imager, what you're doing is you're collecting data or able to see data, everything in the imager's field of view. So everything that it sees, it is giving you information back on. So in this case, we would use a scanner, excuse me, a imager on the hot spot or hot side. You could use it on the kiln. We still recommend a scanner on the length, but there are advantages to having a thermal imager in this application. And then here, what I've got shown is 2 silos. And you might be wondering, well, why would I want to look at something like this? And it's not necessarily looking at the silo itself, it's understanding if you are creating a fire inside. Customers that have had fires that have completely burned all the content, completely destroyed their silos, and have been quite a huge issue to take care of and repair, creating downtime, significant downtime for them. Monitoring the outside of the silo allows the customer to understand if they are increasing temperature internally, and automatically, create a response. So how does automated thermography work? In this case, I'm showing you a picture of our TV40 thermal imager. What we are working with here is a thermal lens, thermal imager, and we are working with a visual lens. So this is the visual side, the fusion side that I showed previously. Continuous monitoring allows you, again, as I've mentioned multiple times here, to visualize temperature, see temperature on everything in the imager's field of view. It captures both the visual and the infrared temperature. And again, this is a product that is designed to be set up once and run 24 hours a day, 7 days a week. This is an extra set of eyes for you to get data on your system that you feel may be critical. From a connectivity point of view, we communicate via Ethernet. We have a version of Ethernet IP, and we also communicate via Modbus. And the product is designed, I've mentioned it multiple times, with the output modules to take data that it collects and send that to a data collection system. That can be just the actual temperature on AOIs, or it can also be images and videos. And then also with the output module, you have your trigger input, which is for background compensation, or it can also be for taking a video of something moving while going past it. One of the scenarios that I like to point out is torpedo cars that carry molten alloy from, say, one facility to a next by rail. If you wanted to take a visual image of that product and save it, if you have a trigger switch such as a physical relay or a physical switch with an output, or a magnetic switch, a proc switch, whenever the rail car goes by and triggers that proc switch, it sends a signal to the imager. The imager takes a video or a picture, and that is then saved or sent on to wherever you'd like it to go. Archiving, our software allows you to archive the videos, archive the data. Again, program an unlimited amount of AOIs. You have the ability to use your max, min, and average temperature data collection to your advantage, or again, you can just use one if you wish. And then areas of interest, we create alarms off of those. So we are looking to take and create a call to action, which then goes into our next portion here, number 4, turning on a light, a sound beacon, getting an email out to a technician, turning something on or something off. I've mentioned that a few times. The idea behind creating an alarm is to create a response, get an action from what the product has seen based on the parameters that you've programmed. Here is a basic structure. What we're showing here is how the unit would connect. So we have the camera either independently or in a pan and tilt. We also have a variety of different enclosures for outdoor or high temperature. The unit is connected to a terminal box or standard PC. It depends on how you're going to be working with this. If you have a connection, say within your plant, and you can connect directly to a PC either at the location or remotely in your facility, you would connect to a PC to operate the software. And then from there, you go out and you can connect to your external devices, your DAC connections, so you can generate the alarms off of the AOIs. In this case, you also have the ability to, if say for instance, this was outside or far away from a, excuse me, a computer, you can create a long distance connection using fiber optic cables. You can go to a remote office location, basically hook up your PC in that location and be able to provide a visual image as well as connect with your DAC, get your areas of interest, and create your alarms. So at this point, asset monitoring remote sites, I've mentioned this a few times, but has this ever been an issue for you? That really is something that a lot of customers have been struggling with here as of recent, is trying to get to all the places they need to without physically having enough time to do so. And in this case, I'm showing another example of an electrical system. In this case, we're looking at a variety of different industrial switchgear. I mentioned that we have the ability to put this product outside in different enclosures. We have used pan and tilts, and we have used hard fixed outdoor enclosures and applications like this in conjunction with one another, one fixed, one pan and tilt. This is a remote site where the customer has the ability to look in on their site or multiple sites without physically going to the location. And one of the things I like to bring up is we had gone out to a site like this, not necessarily this one, and we were setting up our system. We were performing the demo to show the customer how it could give them data and give them data remotely. And the technician that we were with, excuse me, physically said, I'm really glad you guys are here today, and I'm really glad you're doing this, because every time I come on site, and I only come on site once every 3 months, every time I come on site, I'm supposed to bring my handheld thermal imager, and I forgot it. So if that person doesn't make it there for another 3 months, that means the site has not been checked with a handheld for 6 months. A lot can change over 6 months. And if this is a critical piece of equipment, maybe that's something where you feel you might need to have a product like this, where you can install it, look at it remotely, get information from it as you need, and put different alarms in place or AOIs in place with alarms, so if something does begin to go out of parameter from your expectations, you're notified. Physically having a second set of eyes on a product that allows you to have information when you need it. Value of automated thermography. In this case, what thermography offers is an understanding of temperature and everything that the product looks at. It is collecting data, if you wish, at different parameters, once a day, once a week, once a month. It is collecting data only on alarms. Again, this is up to the user. It is able to notify you through output devices. It is able to give you an email. It is able to turn something on, turn something off, and at the end of the day, be proactive rather than be reactive. And we use these, our customers use these systems in safety applications, quality applications, uptime for productivity, and integrated into their networks to be able to collect as much data as they want on a DCS system. This leads me to my next poll question. What is the most important feature to you in an automated thermography system?
I've launched that poll, audience, and this will be really helpful for Craig and team as they continue to work on this system. So your answers here will help for future development of the product. So let us know which of these is probably the most important to you. Is it continuous infrared video feed, data collection, alarming, ease of integration, ease of installation? If there's something else that is important to you, feel free to put it in the questions because Craig will review these afterwards and that information will be helpful there as well. I'm going to give it another 15 seconds or so. Obviously, we'd like to get as many answers as we can here. Think about which of these features would be most important to you for our research and development purposes. I'll give it 5 more seconds. I'm going to close the poll out and then I'll share the answers. Thank you everyone for your help.
Okay, we'll move on.
So Craig, we've got 12% of people saying continuous infrared video feed, 41% saying data collection, 31% saying alarming, 14% saying ease of integration, and 2% ease of installation.
Interesting. No, thank you very much for that feedback. That does help us understand what's most important to you, our customers, and also what people in this type of looking for a product like this actually want. So thank you for that. Okay, I really are coming to my end here. Do you really know the temperature of your critical asset? If not, maybe thermography can help you. I'm hoping that you actually gain some information on how a fixed thermal imager can help in situations where you are trying to understand your system, your critical assets, what is changing over time, collecting the data that supports your need for response to your management team, and allows you to be more proactive rather than reactive. That really is the reason for us going through this and showing you the benefits. If you have further questions, I think we might have a few minutes. If not, is there a way that they can contact me?
Absolutely. Everyone, you are welcome to contact Craig at the email address there. And then feel free to continue putting questions into the questions tool because we'll follow up with you afterward. You've been great. You've asked a lot of really good questions. I'm going to sneak one more question in, Craig, and then we have to follow on to the other slides.
Yep.
Okay? So last question, which is a really good one. Can you use thermal monitoring to satisfy insurance requirements for fire protection and other things?
We have had customers do that. It does come down to what your insurance company will support,
Accept.
but we have had calls and we have supported the installation of products to be able to support that need. So that is a very good question, and it actually has come up more than a few times.
Yeah.
Not today, just in my experience.
Very good. Okay, I'm going to have you forward on.
Yep.
Okay, on the 26th, we're going to be joined by Samantha Lassane and John Burnett for a session on vibration monitoring, because we're just moving on up the PF curve. So Samantha and John will outline where it makes sense to supplement route-based inspections with vibration monitoring and discuss what faults that vibration monitoring detects. We talked about thermography today, so what does vibration detect and compare to that? And they'll have guidance on asset selection and diagnosis and so forth. So check the excelix.com website for more information. If you'll forward one more time for me, Greg.
Certainly.
After I close the webinar, there will be a slight pause. So please stay online because a survey link is going to come up, and we would love it if you could take a few minutes to complete those survey questions, give us your feedback on today's webinar, as well as what other subjects you'd like to see. You can see that link there, excelix.com. There's a webinar section to that. You'll be able to see a recording of today's session there, previous sessions, and then what's coming up. And that concludes today's session. Thank you so much, Craig. This was a fantastic session. I think everybody learned a ton, lots of new opportunities for all the thermal interested people out there. It was great having you on.
Thank you very much. I appreciate it. And thank you for everyone who came to our webinar today and had interest in this product and what it can do for you.
Indeed. So thank you everyone for joining us, and have a great rest of your day, and we'll see you next time.